So as Marcy said, I'm presenting today. I think I know what you're talking about, but I'm not sure. To start off, I'm Jen. I'm a self-taught front-end developer, and as of a couple weeks ago, I became a software engineer at Eventbrite. You may also know me as the creator of Human Wasteland, also known as the Poop Map, particularly those of you from the Bay Area. You may also know me as the creator of another project called Developers, which is a dedication to Mr. Steve Ballmer. So all of that is just a long-winded way of saying that I write code for a living. So a couple of disclaimers before I get started. There are going to be a lot of animated GIFs in this talk. I hope you guys are okay with that. And there might be a few errors in my talk. So if you hear some of those errors, you might be a little bit like this. But before you start to get a little more like this, let's talk about it. But let's talk about it after my talk. So let's go. So as I said, I'm a front-end developer, software engineer, programmer, or whatever else you might like to call me. So some days when I'm looking at my computer, I feel a lot like this. And I think you guys can probably empathize. And sometimes when I'm in conversations with other developers, I feel a little bit like this. So Phil Carlton once said that there are two hard things in computer science: cache invalidation and naming things. And we can see that in some of the vocabulary that we have in programming and web development. So here are a bunch of words that I've seen before just in my general programming life, and a lot of them made absolutely no sense to me. And when I hear people talking about them, I'm just like, I don't know what you're talking about. I've heard that word before, and I think I might know, but I'm really not sure. And so when I ask somebody in conversation, a lot of times I get this look. And that makes me feel like this. So again, our conversations can get really complicated. Our jargon tends to make sometimes no sense, and a lot of our words don't have relationships to the history of the word itself. So today I'm going to talk about a few of those words so you guys, hopefully in conversation, are a little bit less like this. And the next time you hear those words, you feel a little more like this. So first up, parameter versus argument. What's the difference? Is there one? So to find out that answer, I went to Google, of course. And you'll see a lot of people are wondering that question because the third query down, you'll see people are discussing or looking up the difference between parameter and argument. So here I have a function that I created called shark. And below at the bottom line, I'm calling shark with the string left. So how many people think that the parameter is in the first line and it's that variable side? Raise your hand. And I'm just going to raise my hand both times, so I'm not giving you guys the answer. And then how many people think that the parameter is on the bottom line, that string left? Raise your hand. Okay, well, I'm not going to tell you, but let's keep going. So parameter in the online etymology dictionary, which is essentially the history of words, says that a parameter is a measurable factor which helps define a particular system. And that leads me to believe that it's probably the variable that's in the function definition. But when I look up argument in the online etymology dictionary, all I find is a definition discussing how people are arguing with each other. So that really doesn't help me define that in computer science. So I keep going and I check out Wikipedia and I look up computer programming and I see that the term parameter, sometimes called the formal parameter, is often used to refer to a variable as found in the function definition, while argument, sometimes called the actual parameter, refers to the actual input passed. And I think most of us know what can infer from this definition what an argument or a parameter is in that case. But then I also look at it and I wonder, why didn't we stick with the terms formal parameter and actual parameter then? Where did argument come from? So to figure that out, I've got to go down the rabbit hole a little bit. So I started looking up parameters and arguments in math. And here I find that a function definition can also contain parameters, but unlike variables, parameters are not listed among the arguments that the function takes. And I was like, what does that mean? So I was like, okay, Wikipedia, please go on. Keep telling me more. And they say that the variable x designates the function's argument, but a, b, and c are parameters. So you'll see in this quadratic function, for those of you who remember high school math, that x is actually the argument, and a, b, and c are the parameters. And I was like, wait a second. So in math, a is the parameter in that first function, but then in computer science, bar is the parameter in that second function. And this is how I felt. It's like, wait, what? So here's how I describe it. The dog is a parameter. The football is computer science. When the parameter hits computer science, it gets flipped on its end, and it's a different definition. So my takeaway from all of that is that at least in computer science, we know that parameters help define a function, and arguments are passed into a function. So here's the answer. Parameters up on top, arguments down at the bottom in the function call. But all that being said, colloquially, we use parameter and argument interchangeably. So that was easy, right? Okay, next up, scope. So when somebody asks me to define scope for them, I don't know about you guys, but this is how I feel. Like, I really don't want to talk about scope. Please don't make me talk about scope, but I'm going to talk about it today. So first, let's talk about lexical scoping. Again, I went to Google, and what I see is that lexical scoping, parentheses, sometimes known as static scoping, is a convention used with many programming languages that sets the scope, parentheses, range of functionality of a variable so that it may only be called, parentheses, referenced, from within the block of code in which it is defined. Okay. So that definition is a little bit crazy. I don't know if you guys noticed, but in those parentheses, they liken lexical scoping to static scoping, scope to range of functionality, and then called to referenced. So just in one definition, we see terms that are equal to each other. They mean the same thing, but can be equally confusing because we're just using them all the time. The other thing about that definition is they actually use scope in the definition of lexical scope. So you need to know what scope is before they can even define lexical scope for you. So let's break it down a little bit. I'm going to talk about scope, which in the online etymology dictionary again says it is an aim, purpose, object being aimed at, mark, or target, which doesn't really help me define that in computer science. So I keep going and check out scope in computer science and read that a scope is a part of a program that is or can be the scope for a set of bindings. A precise definition is tricky, see below. Okay, so let's see below, guys. Okay, so I keep scrolling down the page, and I get to scope, and I see that in computer programming, the scope of a name binding, an association of a name to an entity, such as a variable, is the part of a computer program where the binding is valid, where the name can be used to refer to the entity. And because I already know what scope is, and I'm sure most of you guys know what scope is, probably at least loosely, this definition makes sense. However, somebody who's never heard of scope before and reads this definition, they probably feel very confused. And so I'd say that this definition it's okay. It's not bad. So I keep reading down the page and get to scope again, and I see that the strict definition of lexical scope of a name or identifier is unambiguous. And I'm like, thanks a lot, Wikipedia. Unambiguous, okay. But then they say that it is the portion of source code in which a binding of a name with an entity applies. And I feel like that's the most basic and easy to understand definition of scope that I found so far. Why wasn't it at the top of my article then? And even more interesting to me is that it was virtually unchanged from its 1960 definition in the specification of Algol 60. And I don't know how many of you know what Algol 60 is, but I didn't know what it was. So Algol 60 is short for the algorithmic language of 1960. And it's actually the first language implementing nested function definitions with lexical scope. So we've had this definition since 1960, and yet scope is so complicated to define. All right, let's go on to lexical versus dynamic scope. So again, in this Wikipedia article on scope, we see that they say lexical scope is the main focus of this article, with dynamic scope understood by contrast with lexical scope. So in other words, they can't even define dynamic scope without first defining lexical scope. Are you guys still with me? So lexical in the online etymology dictionary means pertaining to words. And that doesn't quite make sense to me as related to scope. So I look up dynamic, and I see that dynamic means pertaining to a force-producing motion, the opposite of static, which I also find interesting because we saw in that earlier definition of lexical scope, it can also be defined as static scope. So I keep going in Wikipedia to figure out what the difference is between these two. So they say that for most programming languages, part of the program refers to the portion of the source code or area of text and is known as lexical scope. And I find that interesting because we saw that lexical means pertaining to words. So I keep going, and I see that in other languages, however, part of a program refers to the portion of runtime or time period during execution, and that's known as dynamic scope. But I keep reading, and then I see that both of these terms are somewhat misleading. They misuse technical terms as discussed in the definition. So I'm like, wait, so was what I just read wrong then? And then I keep reading, and it says, but the distinction itself is accurate and precise, and these are the standard respective terms. And I'm like, okay, maybe it was right? I don't know. So I keep reading, of course, and I see that in practice with lexical scope, a variable's definition is resolved by searching its containing block or function. Then if that fails, searching the outer containing block, and so on. Whereas with dynamic scope, the calling function is searched, then the function which called that calling function, and so on. And I find that this is probably the clearest definition of lexical scope versus dynamic scope for me. And all that being said, who cares about dynamic scope? This is a JavaScript conference. So I'm going to just quickly define lexical scope as I see it. My friend wants to define lexical scope as a bunch of rooms, and you sit inside your room, and nobody can see inside your room, but you can see outside of it. So here I say that the box is my scope, and the orange cat can see the white cat, but the white cat can't see the orange cat. And that's lexical scope to me. Okay, next up, recursion. And I said I would do this when this slide came up. Recursion. Okay, so recursion. It means, from the 1600s, a running backward or return, or to run back. And I look up recursion in Wikipedia, and I find that the most common application of recursion is in mathematics and computer science, in which it refers to a method of defining functions in which the function being defined is applied within its own definition. And I was like, wow, that's a lot of like defining, defined, and defined just for one definition. So I was like, okay, let's try to find something a little clearer. Specifically, this defines an infinite number of instances or function values using a finite expression that for some instances may refer to other instances, but in such a way that no loop or infinite chain of references can occur. Let's keep going. So again, in Wikipedia, I see that in mathematics and computer science, a class of objects or methods exhibit recursive behavior when they can be defined by two properties. Number one, a simple base case or cases, a terminating scenario that does not use recursion to produce an answer. And number two, a set of rules that reduce all other cases towards that first base case. And again, because we already probably know what recursion is, this definition makes sense. But somebody coming to this word and definition probably who doesn't know what recursion is probably feels more like this. So I define recursion in its simplest form as a function that calls itself. And that's the way it's been described to me before by other people. However, some people want to get really complicated with it, and so when they say that, when they're explaining the recursion to me, they decide to bring up the Fibonacci sequence. And I don't know about you guys, but it's been a long time since I took math, and I don't even really remember what the Fibonacci sequence is. So I look at this function, and I hear about the Fibonacci sequence, and this is how I feel. So when I asked for a simpler example, another friend of mine brought up factorials. And I'm like, yes, okay, that makes way more sense. Factorials are simple. A lot of people have learned them probably in elementary school. And so I think that's a really great example of recursion. And so when somebody brings up factorials as an example of recursion, I feel like this. Like, yeah, sounds good. Okay, so next up, concatenation. Concatenation in the online etymology dictionary says that it means a linking together or to link together a chain. And I was like, oh my God, we have a word that actually means what it meant in the 1600s, and we're using it that exact way. That's awesome. But really, most of the reason I'm bringing this word up is because it's got the word cat in it. And today is my cat's 6th birthday. So happy birthday to my cat. Okay, now, acronyms. I don't know about you guys, but there are a whole lot of acronyms out there that get really confusing to me. The first of which I get confused all the time, and those are CRM, CMS, and CDN. So just to clarify, CRM is a customer relationship manager, kind of like Salesforce. A CMS is a content management system, kind of like WordPress. And a CDN is a content delivery network, kind of like Amazon CloudFront. And next up is SaaS versus SaaS. Please clarify to me when you're talking about these what kind of SaaS you're talking about. Are you talking about software as a service, like Salesforce? Or are you talking about syntactically awesome style sheets, the CSS extension language? I don't know, but I'm going to get sassy about it. Next up is DOM. DOM has always been kind of confusing to me. This is Grotzer Dom, which is a chapel located in Austria. This is Dom, the indie band. So this is the Dom, which is located in the Alps. And again, we see the term SaaS in this definition. So there are a lot of things called DOM. But the DOM that we are often talking about is the document object model. And the document object model is defined by Wikipedia as a cross-platform and language-independent convention for representing and interacting with objects in HTML, XHTML, and XML documents. And I'm like, oh, that kind of makes sense, but I'm going to search Mozilla Developer Network and see if I can find a better definition. And Mozilla Developer Network says that the document object model is a programming interface for HTML, XML, and SVG documents. It provides a structure representation of the document, a tree, and it defines a way that the structure can be accessed from programs so that they can change the document structure, style, and content. I'm like, oh, that makes a lot more sense. And even better, MDN provides a nice little sketch of a DOM. So I'm like, yay, DOM. Okay, and now GUI and CLI, or what I like to call CLI. Because if we call them GUI, why can't we call them CLI as well? So when I hear GUI, this is what I automatically think of. I have a sweet tooth, in case you couldn't tell. I also think of GUI ducks, which is a bivalve. And GUI ducks is weird because it's not even spelled the way that it's pronounced, similar to GUI. And when I hear CLI, or what I read as Klee, I think of Paul Klee, who was a painter in the late 1800s. But I think most of us know that actually GUI and Klee, as I like to say, the GUI is actually a graphical user interface, and was first introduced in reaction to the perceived steep learning curve of command line interfaces, which require commands to be typed on a keyboard. So the next time you're talking about GUI, if somebody's giving you that weird look like, I don't know what you're talking about, please tell them that it's the graphical user interface. And lastly, AJAX. AJAX, I think personally, is a totally outdated acronym, because who even uses XML? The other thing about AJAX is the jQuery AJAX method has an option to set async to false, which means you could be running SJAJ, aka synchronous JavaScript and JSON. Just saying. So in conclusion, oftentimes when you hear these words in programming, computer science, conversations with your fellow developers, you don't really know what they're talking about. You have some concept, but when you start using them in practice, you're like, oh, I get it, and you just understand it immediately. And because you just get it, it makes it really hard to explain to somebody else. And I understand that difficulty, but I implore you to take the time to really explain those concepts to other people, especially when you're in a big group and someone's giving you a look like they don't understand. Don't be like this if somebody asks you a question. And if you're in a group of people and somebody asks you a question, try to be a little less like this. Just be a little bit more like this. Because it's really difficult to explain these concepts, and we really need to be helping each other out. So let's take a look at this video. So you see number 12 there. She's like, I don't understand what GUI is. Everyone around me is talking about GUI. What is GUI? And other number 12 comes over and she's like, let me explain GUI to you. GUI is the graphical user interface. And other number 12 is like, I understand now. That's what GUI is. So when we're all a little bit more like this, helping each other out, explaining what GUIs are to each other, we can all party together in the computer science jargon land. Thank you.